Okay, hello everybody. Welcome to CS230. Nice to see you here. We'll start proper, and if there's a problem with the voice or anything, if you can't hear me, do let me know. But I'm assuming it's all good on this end. Okay, let's switch to the slides. We're into week 6 already, folks. I mean, I can't believe we've got to week 6. It's halfway through the semester this week. It's been a busy one for you, I'm sure, and for me. And I thought I would finish up a little bit with, finish up this first half of the semester, really, with a little talk on developing web content using models. And the model we're going to look at is called Model View Controller. We're probably going to look at another two, actually, Model View Presenter and Model View View Model, and a little bit about JavaScript frameworks and how those frameworks are built on the models. The reason I do this is because, you know, you've done two big assignments at this stage, and you know, people are naturally reflecting on how they are coding. So, you know, everybody's there thinking and saying, you know, well, was this the right way to do this? How do I go about solving the problems? How do I build web apps? How do I build, you know, games? How do I do all of that sort of stuff? And these are the kind of questions that people are asking themselves and are asking me. And it's a good point and a natural point to actually tell you that, you know, there are models and design patterns and approaches that you use in order to be able to do this. And that's the purpose of this week in this lecture, is to show you some of those patterns and really to show you, you know, how people do solve big programming problems where you have millions and millions and millions of lines of web code. And it will work for small programs as well. It also works in terms of having patterns and designs when we want to have groups of people working on different parts of an application we might have. And you know, by separating the application into the different parts and different components, we can have lots of people working independently and then pull everything together to make your full application work. I mean, you'll know, for example, we don't have a single person sitting there in an office working on Facebook or on Google or any of the other big web apps that we use all the time. So this actually is it's an opportune time to bring you up to date with some of the theory around web development. And these are architectural patterns I was going to talk about a little bit later. Let me tell you in advance, they're hard going, okay? They are a bit tough going, and they really, you know, are helpful when you have a little bit of experience and you have a sense of, I can see maybe how I might use these, but sometimes it takes a while. So there's a lot to do in terms of the descriptions. There are very subtle differences between each of them, the three that we're going to look at actually, and you know, you might get lost, but you know, this is just a first pass. You come back to it, look at this lecture again, maybe have a look at the slides separately, and it might make a little bit more sense. And do look at the lessons that I'll post tomorrow, because they go into some of them in a little more detail, and I'll show you how to build versions of each of these, and I'll show you how to compare them all. That's the plan for today. Midway, I've put some kind of note in my slides to say, tell the students about the assignment 3, which is to build this assignment that deals with tables and manipulating tables. And the reason I do this one is because it's an interesting way to look at a model view controller. In other words, how we might have a view, which is the table that we see, and the model, which is the data, that content that we have underneath, hidden in the table, and the controllers, which are the buttons and things that we press to be able to engage with those. So we have a natural kind of, you know, breaking down of the various components that we could think of in terms of a model, a view, and a controller, if we want to use those terms for this. And then it kind of separates the architectural model from the underlying technologies. So we think in terms of the HTML, the CSS, and the JavaScript, one that provides the structure, one that provides the style, one that provides the interactivity. Well, I want you to start thinking a little bit more about your applications that you develop for the web in terms of the view the user sees, the model, the data that's held in this particular application, and the controller as the way that the user interacts with the actual application. And you may find that you need to use HTML, JavaScript, and CSS for each of those components. And it would be better to think about the architectural structure rather than just the underlying technology structure. And that's the purpose, I guess. Okay, is that clear? And thanks for the hey in the chat. I see you there, and I'm delighted to have you here. Thanks again. Okay, so we'll move on. Okay, so we're in the last week, as I said. You know, this lecture is just going to be like a bit of an overview, the live stream as usual, and tomorrow's lessons will be uploaded. Okay, so we're going to focus on these architectural patterns, as I've mentioned already, and these are applied to most modern web development. Okay, now there are other design patterns that we will apply as well, and I teach a module in third year. You'll see me again next year, folks, on design patterns, software design patterns, and many of those, you know, can apply to your web apps as well. And all of the lectures for the design patterns are also available on this YouTube channel, CS230. You can see if you're interested in how some of them might work, you could have a look. There you see C# rather than JavaScript. But nevertheless, I do talk a little bit about these patterns as well. And the ones we're going to look at are this model view controller pattern, MVC is how we call it, model view presenter, which is MVP, and model view model. And we see a little bit about that later as well. So we're going to look at each model, beginning with model view controller, and then we're going to review the similarities and differences between the various models. Now these are subtle and it's hard going, guys, you know, so I really appreciate if you can stick with me. Okay. There are other design patterns, and we're going to look at these as just a representative sample, if you like, of the design patterns that are used in web development. And these ones mostly relate to web user interfaces and how they're realized. Later on in the module, in the second half of the module, we'll be looking at API development, and we can look at models and designs for that. Okay, so this really looks at those kind of the front end parts of the web that you see and that you engage with. Okay. So we're going to also look at some simplified code examples that illustrate how the models could be implemented using JavaScript in the lessons that follow tomorrow. So in terms of an overview, there's no single way in which a website can be structured. There's lots of ways to do it. And I always say, when I give an example, here's one way to do it. Okay? And you know, you could ask me a question today and I give you the answer. You could ask me the same question tomorrow and I might give you a different answer, because it depends on my mood, my humor, and haven't decided which one is best. Or maybe I learned something in between today and tomorrow that would give rise to a different kind of answer. So, but the solutions and you know, and approaches, they exhibit so many differences. We usually say that the pattern of the websites vary as much as the websites themselves vary. So if you consider a really complex social networking site, for example, you might be familiar with Facebook, Instagram, YouTube, any of these things. You know, they're very complex websites that people use on a very regular basis. But as soon as the user lands on that homepage, the website kicks off and fires off all these data requests to fill in a page with a multitude of components. So if you go to YouTube, you know, it'll know it's you, you know, and if it's you, it will give you all the information that it knows about you or things you might like. It has a profile of you and it's capturing you. And depending on the time of the day, you know, depending on what it thinks your mood might be today, depending on what's happening in the world, you know, all of these things factor into what you see on the page at that particular time. And these are all done with profiling, of course, you know, and analytics and so forth, but really complex stuff happening, you know. So the interface you see will be the one you know and use, but there will be all the stuff around the interface that gives you all that extra stuff, you know. And if you log into YouTube and if you join YouTube and you're not actually logged in, it'll base it on your IP address. And I might say, well, John is always at this IP address at this time of the day. We know it's him, even if it's not actually, he hasn't signed in. So we just still give him the same stuff, you know. So these are how these things work. And we can see how to do all of that stuff later on in the module. So every one of these components, they're designed to render asynchronously. So the failure of a component won't be consequential to the rest of the page. So if you compare that to a website like Google, then Google has a really famously simple user interface on the web. It's just a single box, button, click, search, and do all that work. But underneath, Google.com is without one of the most logistically and logically complex web applications that anyone could ever think of. So much is happening and going on there, you know. And it's so much happening. It's scary. And as Tig says there in the chat, you know, it is a bit terrifying. But you know, you'll learn how to do this and how it works eventually. So what the key term or the takeaway terms you need to think about here are these architectural design patterns. They're the ones that give you the architecture or the structure of your actual web application. So the logic that's necessary to run an application like Facebook or YouTube will be very different to the logic that's necessary to run an application like Google or the one that you're working on your current assignment. Essentially, every Complex functionality is just a simple way in which the front end or the view, the front end will be the view, this is the language you're going to use now, that can reach the appropriate model, okay, to retrieve the data. So there will always be a model and there will always be a view. So you may have multiple views for the same kind of model depending on who's using it. You can think in terms of, I prefer dark modes really to light modes, or, you know, these are different views of the same model data. So the differences in the patterns and ultimately the interaction arise from the way in which the models and the views are actually connected. So we're going to look at the way that these are connected using some standard design or architectural patterns. In other words, there are two ways in which you can have the view of a website, manipulate the model of a website, and that's either using a controller or with a presenter or a view model. And we see those terms a little bit more a little bit later. The takeaway now is that we have data that sits there somewhere in the background. We have some controller or user interface mechanism that somebody clicks or buttons or presses or scrolls or types that changes that view. So every method of communication has its own strengths and weaknesses, and the use of the patterns is to help in developing applications that have a loose architecture that's easy to maintain and test. And using patterns for development results in cleaner, simpler, more manageable UI code. And that's generally the purpose of all of this. And we can have multiple people working simultaneously. That's crucial, of course. So when we study design patterns in web dev, for example, we're interested in the different ways that the states, the models and the views can be interconnected in an app. And you can see how complexities can arise even with simple apps like the one that you did in assignment 2. Trying to get everything going for that assignment game is not easy, and you did good work on this, But when we refer to views, we're really referring to the DOM representation of the user interface elements that reflect the state of some data model, also in the DOM perhaps, or it's held offline in some server. So if you see a table on screen, then that table data is held in the DOM somewhere in the document object model, because it's held in those tag elements, if you like, within the table that's stored in the browser front end. But those data could be populated and taken from a server. So if you're using Excel online, that's essentially just one great big table, but all the data might be taken from some databases. Same kind of structure. So if you can imagine a scenario where watching a show on Netflix or Amazon Prime or Apple or Disney TV or any of your favorite places, as you progress through a season, your data, that's an instantation of some model, is updated. So the state changes when it changes the user interface, the watch lists and all that stuff change. It's automatically updated in your viewing screen. So the view changes. So we need ways to easily send data from the view to the model and ensure that the view accurately represents the current state of the model and vice versa. So you could see maybe from last week's lectures how you could use jQuery to talk to servers, backend, and update models locally and remotely, and then update the views for you. So it all starts to come together, and that there are very well-defined ways of making all this happen. So in reality, we actually tend to use front-end frameworks like JavaScript framework libraries such as Angular, React, and Vue. And these all handle the DOM operations for the view, so once we automatically update the model of an app. And they work for apps that comprise hundreds of thousands of lines of code. So as I said, the three most commonly used architectural patterns in web dev are MVC, Model View Controller, MVP, Model View Presenter, MVVM, Model View Model. And these latter models are derivatives of MVC. So we'll discuss each pattern in order and then look at the similarities and differences. We're going to look at MVC first. So on the right, you can see we have a little diagram of how MVC works. So Jim and Frank are users. They talk to a controller. And that controller can be just some amorphous blob. It can be on the web. You may be multiple controllers, but they could be buttons, anything that take you somewhere. And you allow these embedded in your browser. It allows you to view pages. Okay. And when you look at pages, then you may engage with those pages in some way and ultimately update the model. And that's sometimes called a business layer. And you have all this interaction, so they see what's been happening. So you see there's flow of information between the model, the view, the controller, and the users are at the core. They do all this work. And that's it. Once you get that, you should be fine with all of that stuff. Okay, that's the core stuff. Making it happen is a different course. Okay, so let's look at Model View Controller then. So that's an architectural pattern that was introduced in the 1970s. Checking the times there. And it was first and foremost option to be used in web applications. So MVC has 3 layers: the model, the view, and the controller, unsurprisingly. And it tries to let the developer build an application in a manner where the layers of concern are separated. So it helps in turn to take away all the effort needed to extend, test, and maintain the application. So it means you can still retain your model, you can still retain all your controls, you might update the views, so you might have changed the user interface, or allow people to adapt the interface so it's something that they like to see. So classic MVC, 1970s, it existed at a time when every control and widget that existed on the screen was considered dumb. And every control was paired with its own controller to manage user interactions happening to them. So if 10 widgets or things existed on the screen, then there were 10 controllers that had to exist. So every widget was counted as an individual view at that point. But with Windows-based graphical user interfaces, the system changed the perspective on all of this. Okay, so the controller relationship became obsolete. So the controls gained some intelligence to respond to all the actions that were initiated by some user. And in a Windows world, a view is just some surface in which all the controls and widgets exist. So only a single controller is required, and views can receive events and then react to those controllers, and then reach out to controllers to help for further processing. This is kind of a bit of history. So here are some quotations or descriptions of model view controller. The reason I give all of these different types, it's not to confuse you, is that they all tell you the exact same thing about model view controller. You may find a version that suits you to help with your understanding. So if you read one of these and you understand that one, well, then you get what's happening with model view controller. So for example, the second one, the model characterizes a set of classes to describe business logic. It outlines the business rules for how data can be handled or changed. The model represents a collection of classes that explains business logic. I've said all that already. The model receives input from the controller, decides what data is needed to fulfill the request raised by the controller. The model is capable of doing transactions in databases or persistent storage is needed. Once it gathers the required information, it informs the view about new data by raising appropriate events. So, that's any of these will work for you for the model. And you can look at the slides and find one that suits you. There's a view. The view represents the user interface components like HTML, for example, CSS, jQuery, etc. The view displays the data in which the controller sends back as a form of the result, and the model can be converted into the user interface using a view. So that's nice to be able to look at that. So we just use that one line. But as I say, you can go back through this and find any one of these lines that might help with a description of your understanding. And finally, of course, and unsurprisingly, the controller. So the controller is highly responsive for processing incoming requests, and the controller gets the user data through the model to view. And the controller performs as a facilitator, if you like, between the model and. Okay. Remember, the view is the user interface components such as CSS, HTML, etc., and it displays the data that's received from the controller as the outcome. As I say, these are not meant to be. These are all just individual descriptions from different literature you'll find online and elsewhere. So really, the model view controller design defines this interaction then between the various components. So you can see the diagram down here. You may have multiple models. You have some controller that handles all input and then produces some views for you. So it defines all the interactions between the various components. The model is responsible for managing the data of the application. It receives the user input from the controller. The view presents the model in a particular way. So you can retain your model, and you can change the view, or you can use the view to update the model. Yeah? So you could have a table of data that you present to the user. You can change the style that changes the view. You can have an input box that allows you to change or get data from the user, and then use that data to update the model from the view. And the controller sits in the background. It's happily, making it all come together. You don't often see the controller. You often just see the view. And it's like acts as your mediator between the data and the front end. And yeah, we'll see some examples. Thanks for the question in the chat. Yeah, we'll see some of this as we move along. And we'll talk a little bit. I'll show you a little bit about with the example, with the table example for your assignment a little bit later in this lecture. Shortly. Okay. So in model view controller, the view sits on top of our architecture. The controller sits beside it. Models sit below the controller. It sort of sits between the two. And the view knows about all our controllers, and the controllers know about the model. But the views have no direct access to model. So here's some representations that you see about how the model view controller might look like. Okay. So we have, let me move over a little bit so you can see all of them. So on the left there, we have the model talks to the view via the controller. This is my favorite one. Okay, so we have a model, and the model updates a view, which can be seen by the user, who uses a controller to manipulate the model. This is a bit like how a spreadsheet would work. And maybe that gives you an example there from the question. So you have an online version of a spreadsheet, say, you know, on your Microsoft version of Excel, or you could have like Google's spreadsheet or Apple's iWork software and numbers. You know, your data is saved somewhere in some database, and those data are you crank up your spreadsheet software, it loads the information in the spreadsheet over the web. Then you can change it and update it. So that's what's happening here. So you're viewing the data that's currently there, but you can actually see this data, change the data, and then the controller is responsible for looking at the change to the data and then updating the data model. So if you close your window, that data is still stored in the back end. So does that give you some indication or some help of how the models will use? So you don't have to worry about how the actual data is stored. You know, it could be stored in JSON, it could be in a relational database, it could be in a graph type database, it could be in some proprietary database, it could be in any of these things. All you care about is what it looks like and how you engage it. You as the user deal with the view. And that view has some interface components that you can manipulate those data. A controller sits underneath, making it all happen and talks to the model. And there's lots of examples here. You know, you have a user engaging with a controller, looking at components, and we have model classes or model data. Sometimes we represent our data as classes. You can think of that for you. I've got some questions here you might want to think about. Go back after we've done the lecture when you're reviewing the slides and seeing, is this correct? That makes sense. And again, is this one correct? I'm just highlighting them because I take these directly from some examples that you see in the web. And what's important to realize is that not everything you see in the web or every diagram will be exactly as it should be in terms of the theory. So, you know, you might copy something from the web and think, is that right? Or you might not think, you just say, well, I've just copied it. I'll use it, you know, in my answers or exams or something. But, you know, have a look at what's happening sometimes here in terms. That's model view controller. And intermission, that's my reminder to tell you a little bit about the CS230 assignment. Okay, so what I wanted to do for this assignment is I wanted you to think in terms of about, like, you know, dealing with model data. In other words, dealing with data, displaying those data, updating those data, and manipulating those data. Okay? And that's really what happens in a spreadsheet and what's happened in a kind of table. So I have, for example, a sample piece of software here that I've written. What I've done actually is I have data in a model form. And that model for me is a JavaScript object. Okay. Then this is an example of a five row data model, and this is an example of a 10 row table that's generated from the model. So what I'm doing is I'm separating the model data from the display data. So I want to show you a little bit about how I might do it. It's similar to what the kind of thing you want to do for yours. Let me switch to a browser. So here's a browser, and we'll have a look at this. And I'm going to create a table from a JavaScript object. So what I'm doing here is I'm randomly generating a JavaScript object, and I am then displaying that object. And you can see the data. You can see that the data corresponds to whatever is in the table. But actually what's happening, it does, because there's a one-to-one correspondence. Now, in this particular example, I have no way of changing the data, but if I did change the data, I have to be sure that I also updated the appropriate row in the model here. So the way I do this might be fairly awkward or straightforward, but it's a way to make this happen. So I can just create a table. So I can continue to create tables. So I just randomly generate tables, and every time I generate a table, I just get a new model. So what I'm actually doing here is I'm generating a model, and then I'm displaying the model and dynamically generating the table. So we can look at the source here. You won't see a single line of code, HTML code, that actually for a table. Okay, I'm not writing any of the table stuff myself. I'm creating all that table using JavaScript and manipulating the DOM in the page. I have a placeholder for the table. I have a placeholder for this button here. Then I have this table. And then I have another button space here. And you'll notice that I'm generating all these names, okay, automatically. So, and student IDs, I'm generating data, and I'm calculating an average. Sorry, just let me water, please. And anybody who's, you know, very, very astute and observant will notice that the average is not correct average. There's an error in the code. I inserted an error in the code after I had the working code, so that if I distribute this and somebody tries to use it without changing, they'll have an error. You need to look at all the code that you copy and make sure it actually works. There's an error in the code. Okay, I can show you how to fix it. That's deliberate error. Okay, so let's have a look at how this works. Now, you'll notice these data, by the way, what I did is I wrote a piece of JavaScript that actually generates a name. Okay, there are better ways to do this, but I just did it manually to show you how you could do this kind of thing. There are name generators. So I wrote a little simple name generator in JavaScript. That allows us to be able to, so what I did is I went to the Central Statistics Office from last year, and I got the most popular babies' names for male and female. Then I picked up 100 most popular or most common, not popular, it's not like you can choose your surname. I mean, the most common surname, and then I wrote a piece of software that just generates a random name. Easy to do, because I'm lazy, okay? I'm a lazy programmer. In the Larry Wald who invented Perl sense, you know, I'm as lazy as virtuously lazy, okay? As far as that, you know, if I think I might ever have to do something again, I'll just write a code rather than try to generate all the data, because it's fast for me to write the code to do this than to try to think up of all the names, you know, and have to think them up every single time. So this is the way I do this. Student ID, dead easy, which is a random number generator for that too. And then these are random number generators for each of these assignments. So let's do the important bit. Let's have a look at code. So here you can see that I have my JavaScript in here. I have an external file that contains the table styles, because my table had styles, so that my table styles are here. So I know how all my styles look like, what a few bits and pieces of, you know, of styles that I applied, and they're nice styles, and so it works nice for my tables, so that's okay. I have an external file containing my JavaScript that generates the name of my JavaScript, and that was a very simple JavaScript file that generates names. So you can see the length of this; it just goes on forever. So I basically created a list of boys' names, put them into an array. See, loads of names. I just pulled all these things off the Central Statistics Office. I did the same thing for, gosh, there's so many of them, you know. And I did the same thing, the most popular names for female names, and then I got all of the surnames, and then I created an actual list, and I produced a single function that just gets a random name. Okay, so build a name. Very easy. I also shuffles the names and the surnames so that every time I load this thing, I get different ones. Okay, so I create this array, I shuffle the array, and randomly choose something from the array. So it's not too complex. It's a fairly straightforward thing. But I have this forevermore. Okay, so that's pretty good. And I also wrote this very simple piece of code here that allows me to just get a random name, so just to check it works. You know, so that was my independent testing, if you like, of this model information that I have. So it's model data that I generated, I can reuse. So so I generate a random student number. So that was an easy. There's 2 lines of code to generate a random number for a student number, and then I generated a random grade. 2 lines of code to generate a random grade. So that's everything you would need to be able to do that work. It's not complex. And then I had my so this is the structure. So this is the view. Okay, so this is the view shows a table. So I have a button that says generate a table, create a table from the table object, table data. So in other words, I have a model, okay, that I'm using here, and I create a HTML table from that. And then I show the table. This is where the table will show in the view. And I have a button that shows the table object, and I update the table object. And here's a script. So this is the full code that does everything. Okay, it's not a lot of code in here. I'll post the code for you to have a look. But basically, I'm generating a new table here. So I can generate a table with a number of rows. So, and that's it. Straightforward. I push the data in here, and I just get the number, get a name, a number of students, random. So I just push these rows into the data. And sorry, this is a table model, and this is the number of rows. So easy enough. Calculate the number of assignments, the average grade, and then I just automatically calculate what the final grade will be. And this is the code that generates a HTML. It's not hard to do. You can see there's no actual HTML anywhere. I just have a routine that actually generates a table, inserts rows into that table, and then when I have rows, I insert the columns and headers, and those are the various elements. And once I have the table created, I'm able to just add the actual data from the table object here. Straightforward again. I create a cell, add the data, display the cell. I add the styles and set the styles. Not hard to do, and I use the styles because I've loaded those already from my CSS. So now I update the table view. So I actually view the container that shows me where I want to view the data, and I just add the table that I've just generated. Straightforward. And this shows me this is a very simple 3 lines of code to show me everything that I need to look at the data model. I stringify my JSON and then present it, make it look, and I end up getting. So it doesn't take too long, you know. You don't have to have a random name in the assignment, Connell. I mean, the question is fine. It's just I know that I'm going to need this, and you're going to need this for later assignments in the year, where you're going to have to generating data to add to a database, and you'll probably want to have different names then at that point. And you get tired of making up names soon, so you can use mine or you can use somebody else's. I'm okay with that. That's fine. So that's a little bit about how you could do and work. And you know, as I said, I'm not writing any HTML. All that HTML is automatically generated for me, so it's okay. I also have another version. And if you look at this version, you'll see the average grade here. And if I just generate another one, you'll see I've got the 4-point average grade here. I do it again, I get the letter grade. So I've written some functions that allow me to be able to do the conversions between everything. I think that's required for a later part of the assignment as well. So that's all done. I think in your case, you're supposed to click on this final column to update the grade. But I mean, if I give you the code to show you how to do this, you should be able to figure out the other bit as well. Okay. I don't want to give you the solution. I don't give solutions, but I'll certainly give you something that will help you get to a solution. So, so yeah, and maybe I'll talk a little bit about how I made this piece work as well. I'll make a smaller video and I'll just give you the video. I'll post it separately, but I need to get back to the lecture shortly. Okay, there's a question in chat. Quick question with the assignment. Do we calculate the average of all 5 grades if only 4 have been inputted? Yes, please. Yes. Correct. Yeah, because I know, for example, some of them, there will be dashes here. The one of them, and you need to treat the dashes as zeros, and that's a little bit of conversion work that you have to do in terms of making that happen. So yeah, there's some extra complexities around. So I'll give this code to you. I'll post it to Teams. Well, I'll certainly post it to Moodle anyway, and you'll be able to have a look at this, and it may help you with the assignment. Okay, but I guess the point that's really important here, and we get back to the lecture, is that there was a model data that was generated here. This is the model data, and then I used a way to view this data. Okay, and in this particular example, you'll see that the view differs every time. I change the view, so I'm getting a different view in terms of I'm getting the average percentage here. I'm getting the 4-point average here. Change the view again, I'm getting the average letter here. So the data remains consistent, but the view will be different. And the controller, essentially these buttons act as the controller and do all that work. Okay, so hopefully that gives you some sense of insight into how this kind of thing pulls together and how it all works, you know. And that's really, if you get that, you get everything. So I'll get back to the rest of this now. So that's intermission over. Okay, we now need to think a little bit about model view presenter. So the model view presenter, oh, there's another question there. Okay, so Simon says that only grades should be editable, not the other cells. When editing a row to the table, should we allow editing of name, ID, etc.? Well, yeah, it's if you're at that point, yes. The first time when you create the row, you'll probably need to create the row. They need to create those data. You know, as I said, I'm lazy. I would be just as happy if you created a new row and just randomly generated that part. Okay. If you have, and you can use the functions that I provide. I mean, I'm happy for you to take those functions and methods that I've used to generate names dynamically. I mean, I know some students from the last time I did this kind of work, certainly with this year I gave an assignment in the software design. We looked at we looked at different ways to generate names and so forth. But you know, if I give you this code, I'm quite happy for you to take and change and use that code any way you like. So it's that, if that's okay, yeah, that's okay. That's no problem at all. It's just more work for you if you have to generate a new row. You know, for this particular exercise, just dynamically generate the stuff. Make it easier on yourself. You know, the idea is that people say, well, how much time do I have to give to this assignment and stuff? You know, well, I think it's doable in a week. And one of the reasons I think it's doable in a week is because I'm going to give you a whole bunch of code that will make it doable. Okay, and you can use this and modify this code and get to it as best you can. I know there's students who will say, I want to be able to, you know, the conversation, one student who, you know, who likes to be able to do things in, you know, as little time as possible. And I'm kind of like that student myself. I like to get things done. If I spend an hour on it, you know, then that's grand. But then, you know, not everybody will want to do it. So it didn't take me that long to write this code. I mean, you can see there's not a lot of code in there. You can just go back to VS Code. You know, there's what, 127 lines of code that does all this piece. And I mean, you know, apart from the style CSS, which is not very exciting, and this, which is just like, there's only that, you know, that's the only code there is that. The rest of it is just copy and paste data names. And then adding it, you'd need a small function to add a new row, but that's basically copying some of the material that's done in here. So there's loads of them. The higher parts are things that the higher credit parts are something that will take a little bit longer, of course. But you can do one or two of those. There's lots of them, but I've given you options for how you might, which ones you want to actually try. Some of them are easier than others. And they're capped at 5% anyway. You know, you don't have to do all of them. Although we have students who've done all of them because they want to do this in the past. But yeah, have a go and see. Like, not necessarily this assignment, but there are students who do all parts of every assignment because they want to. You know, and not everybody has time to do that because you're all in different courses. You know, different experiences and so forth. So if you get the base, I'm happy. You know, everybody should be able to get 5%. Okay, so let's get back to. So model view presenter then is an evolved version of model view controller. So the MVP is a user interface architecture pattern. It facilitates automated testing and improves the separation of concerns and presentation logic. So the input begins with the view, not the presenter. Okay, and there's a one-to-one mapping between the view and the associated presenter. So the view holds a reference to the presenter, and the presenter also reacts to events being triggered from the view. So it's aware of the view. So the presenter updates the view based on the requested actions, and it performs on the model, but the view is not model aware. So it's a nice way of doing this. So it's basically, you'll see the controllers are kind of gone. It's sitting there in the view, if you like. So the presenter updates the view based on the actions it performs on the model, but the view is not model aware. It's still not model aware. So in this pattern, the view receives the events, calls the presenter as needed, and the presenter is also responsible for updating the view with the new data that's generated by the model, and the view manages and displays the page controls. It's a bit like what we did actually in that example there, you know. In MVP, the presenter assumes that the functionality of this broker. And in MVP, all presentation logic is pushed into. So there's two variants. There's passive view, supervising controller, and the MVP passive view. The view doesn't directly access the model. In MVP, supervising controller, the view can access them. And that just looks like MVC again, but don't worry too much about the differences. You can see some differences, but if you go, there's some really nice descriptions here. You can click through to this link and you'll see them. And I will do more a little bit later as well. I say on our question in chat there, do you need to use JSON for the assignment? You don't need to use anything specifically for the assignment. You can, as I said to you, there is one way. My solution for that table manipulation is one way to do it. Okay, and you could start with a pre-built table and then manipulate that from in DOM. You know, it's no problem. You can just hold all the data in the actual table without ever having JSON separate. The point I'm trying to make with the solution that I showed you was I'm separating the data from the view of that data. So I have great control over how I play with those data. And that's why I'm using JSON, because I taught you about JSON previously, and JSON is great for moving and shipping it around back and forth, data back and forth across the web between clients and servers. And it's a way we will do that a little bit later. So I want you thinking about how you represent things with internally in your program in JSON that we can then make JavaScript objects from. Then we can use in those JavaScript objects, we can then generate views or user interfaces from these, or move them around across the web using jQuery and Ajax, which we saw last time. So the reason I show you something is that it builds on all of the things that we've looked at previously, so that you have some kind of understanding of, you know, the way the web is organized and worked. And sure, you know, you can say, I'm not going to use JSON. I'm going to completely ignore that. Or I'm going to just, but, you know, why would you ignore the technologies that are there that make life easy for you? And you will use them a little bit later. But for me, I'm just happy to get a solution that works. Okay, if I get it works, I'm happy. You know, it's great to see, and I don't mind. I don't control in any way the solutions that you give. I've never controlled the solutions that people provide. If it works, they get the marks. I might have preferred if they did it a different way, you know, but my priority is that you fulfill the brief and deliver, because if you're working in an organization, sometimes it's about delivering the result, not how you deliver the result. Computer scientist and the theoretician inside of me will say, yes, of course, yeah, we do need to know how it all works and that it's a good solution and so forth. And is it the best one and all that? But, you know, for assignments, just get it done. I don't mind, you know. Sorry, I probably went off on one a little bit there, but I hope I answered your question, you know. Yeah, and in fact, you don't even have to use tables, okay? You can build tables using divs, okay? Well, I don't know why you'd want to, you know, because the whole point of having a table is to have a table so we can build tables. But you could actually do all this. I could have done all of this with divs and they completely ignored the table command at all and just built everything with nested divs. Could have done that, no problem at all. And if you can go and check in the web, you can say, how do I build tables using div elements? You'll see how to do that. Easy. Tables got bad press many years ago because people were using tables to structure pages, but that was really, really, really decades ago. And they haven't recovered. But you know, the reason we have a table and you use a table element if you're building tables, that's why. Okay, let's move on a little bit. I hope that answers your question. Once again, you can look at the model view presenter. You can see there's all sorts of models. The model descriptions haven't changed. I put these here for you so you can see this. A little bit later. The view hasn't changed. The presenter is here that it replaces this controller. So the presenter, you know, if we look at this model row here, the presenter takes the responsibility to address all of the UI events on behalf of the view. So it provides the input from the user, takes the help of the model to filter data, to configure the results of the view, and the view and the presenter are entirely distinct but communicate with each other through an interface. That's the kind of thing that's happening in that example that I showed you. Again, you know, any one of these rows would be fine for you to help with understanding. If I got these back from you in an exam or something, this would be fine. So, So here in the model view presenter design pattern, I've given you another diagram that we have, and it's here the presenter manipulates the model, and each presenter has a view interface and a view. So it's very different from the one that we saw last time, where the controller sat across all of them and it dealt with all the variables. Okay? And here we have different models. And sometimes you might have a presenter that deals with multiple models simultaneously. So that, it's kind of, it's a nice approach. Okay? And again, we have some nice visual representations of the model. Okay? And you can see this. And I think, you know, if you click through to the link here, I mean, I'm giving you these examples here, but you can see the little error. If you look at the slides or the PDFs, it'll take you through to the article that describes this and where I took this particular example from the web. Okay, so please use and you can have the actual. So it's nice. We have the presenter deals with the view, and the view presented, the user here is quite happy, talks to the view talks to the presenter, and the presenter talks. It's more subtle than model view control. Model view. There are some differences. The view is loosely coupled, and if you want to look at the differences between these, you could actually, excuse me, you could look at these diagrams on the right. There's nice examples of each of these, and that'll give you a key. So if you understand the diagrams here, it'll tell you about how they're organized. And again, I've given you some examples of the differences between them. This is just the slide. I'm not going to go through it again because I've talked about them already, but this particular one here tells you a little bit about the differences between these two here, and you can have a look at the key differences and in your own time. This just summarizes them. And here's a nice Stack Overflow article on the differences between MVC and MVP. It's really worth reading. It's a super. Final bit is this model view model, and this is nice because Angular is kind of based around this. Okay, AngularJS. So the popularity of the format can be attributed in no small part to the fact that it's fairly straightforward to understand in comparison to the other design patterns. At face value, the simplest way to connect a disjointed model and the view is to create a controller that manipulates the data model. This is an indirect approach that allows the view communicate with the backend. Isn't ideal for every application. So if you want to build something as a single page application, it doesn't work very well. So another popular method then is to connect the view to the model through something uncreatively called the view model. So unlike the controller method, the view model relies heavily on the front end of the application. So we have this model view model, and it's referred to as the model view binder sometimes if you're using the .NET platform. I mean, I've seen this when I've been teaching the .NET as part of my and C# with CS230. But yeah, it's useful. So really what's happening, and I guess it gets back to that question. Yeah, like a comment in 1999, tables were the devil. Yeah, I used to do this myself when I was a naive web developer, but you know, that was back in the day when you needed to control everything. You know, we didn't have online databases. It was, you know, don't forget I'm old, so I see I've seen so many variations of all this works, but something to think about. And I get back to your question. Actually, a good question earlier about maybe it wasn't here, maybe it was somebody in Teams who mailed me, about making the cells content editable and then connecting the content editable cells to the data so that you could update all the cells. That's very much model view model, because you know, if you use the table essentially to hold all the information, and then you know you use content, make it content editable, then you know it's you're holding all the data in the same space, and the model is updated at the same time as the view is updated, and it's really nice. And that's a good example. I can't remember who asked me. Probably won't share the name now if I do remember, but yeah, this is really like the model view model. And really what's happening is that you have a variable or a model, and if you update the model, you automatically update the view. And then if you update the view, it automatically updates the model. So the whole point of this model view model is to have where you've got highly interactive front-end environments where you're displaying something or showing something, and you can make it work that way. So what's important for us is this whole notion of single page applications, and we see this a little bit later. They work really well with view models. Simple allows the view to directly communicate with the backend. So because of this, MVVM SPAs can move quickly and fluidly and save information to database and continuously. Google Docs, again, perfect example. I like the table that you're doing. If I asked you a little bit later to be able to take the table that you're working on now and have an associated database with this, and then you'd want to be able to update the database every time you make a change to the front. So, I mean, I might ask you to do that. You never know. Anyway, there's a reason you're doing this assignment. To set the groundwork for later. Okay, so there's lots of descriptions here. Excuse me. As seen in the case of MVC and MVP, the model here is used to describe the business logic. A set of classes characterizes it. It works on to design business rules for data and how data is changed. Again, with the view is the same, but like the view model, it's the responsibility of the view model to present methods and functions. It needs to present commands to operate the model, uphold the state of the view, and activate events in the view. We'll see a little bit more about that a little bit later when I talk about JavaScript frameworks in the next set of lessons, tomorrow's lecture. So in summary, MVVM, it facilitates the separation of the development of the graphical user interface, the front end, from the development of the business logic or the back end. Okay? It's sometimes called a value converter. That means the view model is responsible for exposing or converting the data objects of the model in a way that objects are easily managed and presented. So in this respect, the view model is much more than a view and handles most of, not all of, the actual display. There's something called bidirectional data binding or two-way data binding associated with the view and the model. In other words, I'm saying to you, update the model, it automatically updates the view. If you operate on the screen, if you change the view on the screen, it automatically updates the model. This is bidirectional data binding. And that's crucial, and you'll see this with Angular. JS. So it comes with flaws too, because it relies on data binding. The view model consumes a considerable amount of memory in comparison with the other ones. You know, a lot of work happening, you know, and you have to have all these libraries built in. But the creator of the pattern, John Grossman, said that the overhead for implementing MVVM is overkill for simple UI operations. You don't always have to use these. Large applications that use the view model regularly become incredibly difficult to run. So MVVM pattern is mostly used for single page applications. And we have some examples of how these work. The classic one is up here, the model, the view model, and the model. And you see this is all about two-way binding, okay? And you'll see a little bit more if you click through on these, and you'll find that some more detail. I'll talk about them in the lessons anyway. You can compare all the various models if you like. What I've done is I've taken out all of these diagrams and I can show them to you, and you can actually see the difference, the structural differences. And I've given you some examples of how you might compare all the details if you're ever asked. I won't go through all these now because I'll be doing them again. So you can, sometimes you're asked in interviews actually about all the patterns, you know, this one, MVC versus MVP versus MVVM. And, you know, it's important to realize that one's derivative of, the latter two are derivatives of the main one. And the key difference is that their dependencies one layer has another. Okay? But again, you can have a look at this slide and in your leisure and see how it goes. And then with practice, you'll get it. As I said, there's a lot of content here so that you can come back to it a little bit later. It's a lot to take in one. So thanks for attending, everybody. I'm glad I managed to lighten it a little bit by adding in something about the assignment. And seriously, thank you. This material is tough going for everybody, and it needs time to assimilate. I couldn't expect you to get it all at this point, but if you were to take away something from this, it would be, it's a great idea to separate the data from the view of those data from the controllers that are responsible for engaging and changing the data or the view. Okay? Absolutely essential. That you get this. The ideal situations would be where you have this two-way binding happening between the on-screen controls in the view and the model. So that if the view changes the data, it automatically updates the model for you. The model changes, data changes, it updates. And if you get that, you've got this. Okay? And you know, the rest of it is just embellishment. You'll do fine. Have a look at the lessons that follow, give some examples, talk a bit of Angular, you know, talk about some of the examples, some JavaScript demos of all of this happening. It's It's a bit hardcore, but you know, I do need you to have seen it, you know, at least, and have some sense of understanding. Okay. Thanks again for coming. You're very good. I've gone a bit 5 minutes over there, so I do appreciate you still staying in lecture and the chat. And good luck with the assignment. And I will post all of the code that I showed you about the tables, and I will post another small video, probably just to Teams or something, or to so that you can see how to maybe do the grades and switch between the different representations of the grades, and take my code and play with it and do a fabulous assignment. Okay, have a great evening. Thanks again for coming along. Bye bye.